the Earth's magnetism. You all are aware about that, but here we are going to elaborate our concepts. In 1600, William Gilbert first described that the Earth behaves like a huge magnet. We all know that surrounding Earth or at each and every point on the Earth's surface there is a magnetic field. If we just hang a bar magnet, then it points or it after some rotation or oscillation it stays in the north-south direction. It gets its position in the north-south direction. Why? Why a bar magnet always pointing or always gets its position in the north-south direction? Why it is? It is due to the magnetic field, due to something, right? And all these things experimented, and from there in 1600 William Gilbert gave a statement that Earth behaves like a huge magnet. The magnetic field lines of the Earth resembles that of a hypothetical magnetic dipole located at the center of the Earth. That means if we place a magnetic dipole at the center of the Earth and study the magnetic field due to that magnetic dipole, then that will be same as the Earth's magnetic field, and from that we can say that Earth behaves like a huge magnet, that is magnetic dipole. The location of North Pole, now I have to draw a picture. This is our Earth. This is North Pole, this is South Pole. That means, or we can write this as Ncert and this is Jee. It is rotating like this. Ncert is the geographic North Pole, this is geographic South Pole. And this is the axis of rotation, and this is called geographic axis. Geographic axis. We have studied this from our geography in lower classes, right? And the location of the north magnetic pole is near the North Pole, but not at the geographic north. It is at a latitude 79.74 degree N and longitude of 71.8 degree west, and that is somewhere here, somewhere at the North Canada, somewhere in the North Canada. And magnetic South Pole is at 79.74 degree S and 108.22 degree east, somewhere at the Antarctica. That means this is the North Pole hour and this is South Pole. And just join this. This is our SM and this is our NA. And this line joining between NM and SM, that is magnetic North Pole south pole gives our magnetic axis. There is some confusion between our what we are going to say between the names, that is our conception or the nomenclature of the poles. We have write this as a name, that is north pole. But magnetic field lines due to Earth, enter in this region. That means magnetic field lines are like this. But and enters and living in this position. But our previous conception was that magnetic field lines are living from north pole and living from entering at the south pole. Right? This was our previous conception. Right?
Yes, sir. Yes.
Okay. Now see here, we have named this pole as north magnetic pole and this is south magnetic pole. Right? But magnetic field lines are entering this north magnetic pole. This makes some confusion. But to remove this confusion, just remember one thing. The pole, north pole and south pole of our magnet, what we have defined. If this is our magnet and just hang it from the center of mass, it stands in the north-south direction, and we have said that this is north pole, this is south pole. But this north pole is not the north pole. This is the north seeking pole and this is south seeking pole. We abbreviated the term as north pole and south pole. Actually, north pole of a bar magnet is north seeking pole. That means it points to our north pole, north geographic pole, and south pole is points to our south geographic pole. This is actually, this is our what? If this is south pole, this is not a south pole. This is south seeking pole. We abbreviate this as south pole. It gives the direction of south side. It gives the direction of north side. North pole is the north seeking pole and south pole is the south seeking pole. That means if we write this as north pole and this is south pole, then according to this convention, the north pole of a bar magnet is not north pole, it is the south pole, and south pole of a bar magnet is not the south pole, is the north pole. If we take the convention of north pole, south pole of Earth's magnetism, right? And you may change this also, right? You can say that magnetic north pole is actually our convention. According to our convention is south pole, and magnetic south pole of Earth is a north pole according to our convention, previous convention. You can say that. Clear? And in other convention also, this is taken as red pole and this is blue pole. Red pole and blue pole also. North pole, magnetic north pole is termed as red pole, magnetic south pole is termed as blue pole. The convention arose because the magnetic north was the direction to which the north pole of a magnetic needle pointed, and the south pole of a magnet, north pole of a magnet is named so, and south pole is the south seeking pole, and that's why it was named as south pole, because it points in the south direction. in reality, uh, what we want to say that this Na, that is magnetic north pole, behaves as south pole of a bar magnet, and this Sm, which is the magnetic south pole, behaves like a north pole of a bar magnet. Just replace this thing. That magnetic north pole behaves like a south pole, magnetic south pole behaves like a north pole. Just replace north pole of a bar magnet. Just replace this thing, you may get the clear idea. Now the magnetic field, due to Earth's magnetism, magnetic field or the magnitude of the Earth's magnetic field is about 3 into 10 to the power minus 5 Tesla. 3 into 10 to the power minus 5 Tesla. This is the order of the magnitude of the Earth's magnetic field, and it changes from place to place on the surface of the Earth, and also it changes with time at a given place on Earth. That means at this point, at Raghunathpur, at different time of the year, different time of a year, magnetic field changes, and in different year also it is changes. And there is many reason for the change of the magnetic field. Cause of this Earth's magnetism. What is the cause of the Earth's magnetism? Many theories prevail regarding cause of the magnetic field of Earth, but exact cause is not yet known. In different times, many theories comes, and many theory can justify the Earth's magnetism, but till now, actual theory is not discovered. The earliest theory that magnetism of Earth is due to its magnetic materials or magnetized materials inside the Earth, and which is rejected because there is no sufficient quantity of magnetized material inside the Earth, and we all know that there is a huge temperature. There is a huge temperature, very high temperature inside the Earth, and at that temperature, we all know that at that temperature there is no magnetism of a material. Is it clear? First theory was there is a large number of magnetized material inside the Earth, and due to that Earth shows the magnetism. But this was rejected because there is no sufficient quantity of such materials in the Earth, and the material will not have any magnetism due to very high temperature inside the Earth. Second thing, atmosphere of the Earth consists of charged particles, right? Mainly electrons and ions. These charged particles are in motion. Why these are in motion? Because Earth is rotating. So the atmosphere surrounding the Earth is also rotating. Therefore, ions and electrons are rotating. And if a charged particle is rotating, then it sets up current. And current is equivalent to magnetism. Right? And that is the cause of the Earth's magnetism. This was the second theory. Third theory. Magnetism of Earth may be due to basic magnetism of the Sun. Because Earth is supposed to be part of the Sun. Sun has magnetism, and Earth is a part of the Sun. molten fluid. Earth has charged molten fluid. The charged fluid rotates along with the earth and sets up currents, which may be the reason of Earth's magnetism. And this effect is known as dynamo effect. See here, inside the earth there is a molten fluid, rather a charged molten fluid, and earth is rotating. So this charged particle or charged body is also rotating, and that sets up currents, and due to that current there is a magnetism, and that is the reason of Earth's magnetism. And this theory is called or this effect is called dynamo effect. Now every substance, we know every substance consists of protons and electrons, and protons or electrons are charged particles. When earth rotates, substance is rotating, and substance is rotating means electrons and protons also rotating. When earth rotates, they set up circulating electric current, which may be the reason of Earth's magnetism. There are many theories. We have already told 3 or 4 or 5 theories. It is now considered that the cause of Earth's magnetism is due to the circulating electric current inside the Earth. Magnetic field of Earth can be treated as arising completely from the electric current of some kind, because we have already told that magnetism comes from the electric current. That means Earth's magnetism also due to some type of electric current or some kind of electric current. The pattern of magnetic field lines due to Earth's magnetism is distributed over the surface, and these magnetic field lines are disturbed by solar wind. The solar wind consists of charged particles, mainly electrons and protons. These charged particles are trapped near the Earth's magnetic poles. Thus, magnetic field at different places on Earth is different. The magnetic field lines due to Earth's magnetism are parallel to Earth's surface near the equator and perpendicular to the Earth's surface at the poles. At the poles, magnetic field lines are perpendicular, and at the equator it is parallel